Word problem involving maximum or minimum of a quadratic. So right away, those two words instill in me max means that I had a negative a value. And so my parabola opened downward. And then a minimum tells me I had a positive a value and my parabola opened upward. So right away, knowing that I'm going to be looking for max or min, I know what my parabola looks like. I know that the maximum is going to be with a parabola opening down, and the minimum will be with a parabola opening up. The x value of that max or min will be the axis of symmetry, which is our opposite of b over 2a. And our y value is whatever the function is, whatever function we have, and we plug in this answer. So we plug in what we get for x, and that will give us our y value. So those are the things that we want to be thinking about. And again, these are the vertex. The max and the min are found at the vertex. And to find your vertex, you find your axis of symmetry, and then you plug it into the y value. So two answers are possible. We could be answering for x or y, depending on what the question is asking for us. So first we want to analyze what are they asking x to be in this problem, and what is y going to be. So a medical equipment industry manufactures x-ray machines. The unit cost, C, the cost in dollars to make each x-ray machine, depends on the number of machines made. So if x machines are made, then the unit cost is given by the function 6/10 x squared minus 252x plus 31,529. How many machines must be made to minimize the unit cost? So we start dissecting. We're looking for x, and x is machines made. So x is machines made, and then our cost, our unit cost, is that's what C is, which is like our y value. So C of x is like saying y, and so that's going to be our cost. So now we read the question again. It says, how many machines must be made to minimize the unit cost? So it's asking us to find machines. So what is asking us is to find x, the minimum value at x. So it wants the x value of the vertex. So we're going to start, if I want the x value of the vertex, I'm really just looking for the axis of symmetry. So x will be the opposite of b over 2a. And analyzing my equation, a is 6/10 and b is negative 252. So we're going to go ahead and put that in our formula. The opposite of negative 252 divided by 6/10. 2 times 6/10. So we're going to open up the calculator. And we want to take the opposite of negative 252 and divide by 2 times 6/10. So undo there to delete that 0, 6/10. There we go. So we get 210. So our answer for x equals 210 machines. All right, so in our next situation, a ball is going to be thrown vertically upward. So that's just thinking about in the person standing here, and they're just going to throw a ball in the air, and it's going to go up, and then it's going to come back down and land on the ground and probably bounce a little bit and then go flat. So after t seconds, its height is given by this function. So the height will equal 56t minus 16t squared. And after how long will it reach its maximum height? So again, we're worried about what do t and h stand for. T is our seconds, and h is our height. So we read the question again. After how long will it reach its maximum height? So how long? Again, that's kind of cryptic. So it's asking for time. So it wants to know time. So again, I'm finding t in this problem. So what is the time it will take to reach the maximum height? So if I'm finding t, that's like our x, and h is like our y. So we're really concerned about the axis of symmetry again. So our axis of symmetry formula is the opposite of b over 2a. And we're not really using x in this problem, we're actually using t. So we're just going to transform x into a t, and we'll have the opposite of b over 2a. So our t will be negative opposite of 56, because b is in front of the single variable and a is in front of the variable squared. And then we'll have 2 times negative 16. So we'll go ahead and do that calculation. Negative 56 divided by negative 32. And we end up with 1.75 seconds. So the time it takes for the ball to heat, if we draw in the XY coordinate plane, right, this is t for time, and h for height, it's going to take 1.75 seconds. And that's really reasonable. If you think about throwing a ball in the air, it doesn't last very long in the air. So it goes up pretty fast and comes down quite quickly as well. So another problem here, a ball is thrown vertically upward after t seconds. Its height in feet is given by the function h of t equals 72t minus 16t squared. What's the maximum height the ball will reach? So the maximum height is what we're going to be interested in. So again, we have t, which is our seconds. And then we have h for our height. So the question is asking us for the maximum height. So we need the y value of the vertex. So what we're going to do is we're going to take our axis of symmetry to find t, and then we'll plug it in, and that will lead us to finding h. So our axis of symmetry formula is for x, which is the opposite of b over 2a, but we're going to transform that and make it be t, because t is like our x value. And so we want t to be the opposite of b over 2a. So our function is not written in standard form, but we can easily fix that. So I'm just going to put the t squared value first, so negative 16t squared, and then we have plus 72t. So now we know a in this problem is negative 16 and b is 72. So when we go ahead and find t, we're going to take the opposite of 72 and divide by 2 times negative 16. And you're going to see negative 16 a lot, because that is the speed or acceleration of gravity as it comes back down to Earth. So, which is 32, it's half of the acceleration of gravity. So what we're going to do is just go ahead and do the calculator. All right, and so we want to take negative 16 divided by, excuse me, we actually want to take the opposite of 72 and divide that by negative 32, 2 times negative 16. Undo there to go back. There we are. We get 2.25. So our t is 2.25. And again, our t is referring to our seconds. So 2.25 seconds to get to the top. But we're not worried about the time in this problem. We actually want the maximum height. So that's the tricky part about these problems, is remembering what you're solving for. So the maximum height is found by plugging in our t value into our function. So we want to take the height, or h, at 2.25 seconds. So we're going to go ahead and just go back to the original 72 times 2.25. Again, it doesn't matter. You could use the way we rewrote it, but I find it easier to just subtract from a positive than it is to add a negative. And we need to square that. So again, we'll need the calculator again. So we want to take 72 times 2.25 and subtract 16 times 2.25, and then I'll square it outside of it. And that go ahead and tells us it's 81. So we get 81 feet for the height.